Please check for a moment. I'll join again. There seems to be some network issue. Please tell me, can you see the screen properly? Okay, fine. So last time we have talked about TCP having dynamic buffers. Receiver may declare some window size and it need not to be same throughout the connection. It may be increased or it may be decreased based on the availability at the receiver. Receiver may even declare zero window size. Which timer comes into the picture at that point of time? Yes, persistent timer. When the timer goes off, we send the dummy segment to check whether receiver had sent updated window size and we missed it. Otherwise, we continue probing the connection. So, and we have already talked about whenever we are going for three-way handshaking or connection establishment, at that time MSS will be negotiated. MSS is maximum segment size. TCP is a byte stream protocol. Each byte is numbered. Whatever is the number of the first byte, that is going to be number of the segment. And then we have talked about flow control. This is also, when we say dynamic buffer management, there is nothing but the flow control, because our TCP's receivers or capacity will be tuned at the transmitter and then only data will be sent. So I think now we are ready to look at the TCP header. So everyone, look at this header and can you tentatively tell me, see, up till now, 1, 2, 3, 4 and 5. These 5 rows are of compulsory header. Whenever you say TCP segment, they always will be there. And these options and data. It is written options are of course optional and data can also be optional. Can you tell me when data will be optional? Why wouldn't you send data? If you didn't want to send any data, then why would you go for the connection? Yes, acknowledgement. Very right. In the case of acknowledgement, data will be optional. Also, when we are going for connection establishment process, then we are exchanging the segment. At that time also, we are not going to send the data unless the connection is established. So, okay, again I'm coming to the question. What do you think is the size of compulsory header? Mandatory header, how many bytes are there? You can actually count that based on the information which you have. Yes, it will be of 20 bytes. See, port address is of 16 bits or 2 bytes. Destination address is of 2 bytes. That means this is 4 bytes. One row is of 4 bytes. In year written also 32 bits. And we have such 5 rows. So 4 into 5, 20 bytes will be there. What is the job of source port address? Why do we need to send source port address? When we are sending a segment at that time, destination port address, I think we understand that we have to send this data to that particular application. Just reaching the destination computer by using IP address is not sufficient. We have to say that to which application this data should be sent. But why source port address? Can we skip that? Yes, TCP is a reliable protocol. Acknowledgements will be sent back. So unless you send the source port address, it will not know when to send the acknowledgement. Okay? Where to send the acknowledgement. So it will be sending the source port address. And even TCP is used for bidirectional communication. So when you are sending something, other party also wants to send you something. It wants to send you data which you asked for. So if your source port is not mentioned, it will not be able to revert. So source port address is of 16 bits, 2 bytes. Destination port address is 2 bytes. When you are sending query to, let us say, FTP server, then can you predict one of this? If you are sending FTP server query to put a file, let us say you want to put a file there, then can you predict any of this field? What will be the value of source port address and what will be the value of destination port address? I think you used FTP in the laboratory. So I was actually, trying to make you recollect the point that servers function of well-known port addresses. Do you remember that? Servers function of well-known port addresses. So when you are a client and if you are sending a query or request to FTP server, then in the destination port address, FTP's port address would be there. Are you aware by chance that what is the well-known port address for FTP? Yes, actually it functions on two. One is for data connection and one is for the control connection, 20 and 21. These are the two port addresses assigned to FTP. Like when you send control information, when you are sending ls, it is showing you the list of that. If you are connected to the Linux server, when you are saying that get then file name or put then file name, then file will be copied from that computer to your computer in case of get. And when you are going for put, then for your computer it will be kept on the other computer. So this control commands will be traveling through control channel and data will be traveling through data channel. There are two separate, of course, virtual channels in FTP. So I think we require this at the transport layer, and we didn't even discuss this in case of UDP. In UDP also we had source port address and destination port address. I just want you to know that any transport layer protocol, whether you design a new one or you upgrade this, you cannot get away with a source port address and destination port address. They are mandatory. Now moving to the next field, sequence number. Sequence number is 32 bits long, that we have already discussed in the past. Sequence number is 32 bits long in case of TCP. What will be the sequence number in first segment when you are sending the connect request? when we are sending the connect request. See, channel, if you are talking about, like, if you are going for FTP, then in case of FTP, it is always connected to which port address? It is 20 and 21. If you're going for HTTP, then you already know that this is the port address which is used. Like, if you have developed one application, you have developed one server in the laboratory and you have assigned 13,001, then somehow we need to let know the clients that 13,000 something is the port address, then only they'll be able to approach you. But the well-known port addresses are fixed, like R10, it is the ambulance, so that we don't need to search that. Very easily and conveniently we can do it. So I was asking about sequence number. In the first connect request, which we are going to use in three-way handshaking, what will be the sequence number? Random. Yes, Dev, Janil, Priyanka, it is going to be random. So we are not starting with 0. It could be 13,000. It could be 35,414. It could be anything. And then in the sequence, each byte will be numbered. Now, acknowledgement number is the number which receiver will be writing whenever it is receiving byte X. It will be writing here X plus 1. Acknowledgement number tells you that what byte your receiver is expecting next. So it will be writing X plus 1. If you send, let us say, again I'm repeating this, first segment of 450 bytes. It is sent first segment of 450 bytes. And if our initial sequence number is 100. Initial sequence number is 100. And we are sending the segment of 450 bytes. And that has been successfully delivered. Will you be able to tell me what will be the acknowledgement number in this case? See, the first one is 100. I said 100, right? So if it is 100, then what will be in the 100 to 549? These are 450 bytes, right? 100 to 549. So when receiver receives this, it will be sending acknowledgement of 550. So Vimal, Prince and Channel, that is true. Now there are 4 bits, that is TCP header length 4 bits. So we actually, it is scaled down by, tell me, scaled down by just like IP header. Your IP header is scaled down by 8. Are you sure? 4. Yes, 4. Like if the compulsory header is there, just the mandatory header is there, then what will be the value of TCP header? If header length is 20, then this value will be 5. That is true. And please remember, this is same for IP header and TCP header. So minimum legitimate value of TCP header length is 5. It cannot be lower than 5. If it is lower than 5, then there is something wrong here, because 20 bytes are minimum required. And the maximum value can be 1111. If it is 1111, that means it is 15. Then 15 into 4, that will be 60. 20 byte compulsory header is there. That is how maximum options which we can accommodate will be 40 bytes. Then next few bits are reserved. Initially when TCP was designed, then only 6 flags were there. And the 6 was left blank. And then 4. Okay. 4 plus 6 plus 6. 4 bits were left. But then afterwards 2 flags were introduced. So we have just 4 bits left now. They are reserved for the future flags in case if we find something, or probably one field if at all it is required. So now this, let us start one by one flag. Let me start with the acknowledgement flag. Okay. So if the value of acknowledgement flag is 1, that means this particular acknowledgement number is a valid number. Otherwise, this number will not be processed. Whenever you are sending a valid acknowledgement, then the flag will be 1 and corresponding value will be written in the acknowledgement number. Sometimes when you are sending the first segment, let us say when you are going for the connection request, at that time you are not sending acknowledgement to anything. Then this acknowledgement flag will be 0. Then whatever is written here, it will be ignored. We cannot skip this. Okay, you cannot skip this because it is interpreted like that. First 16 bits source port address, next 16 bits destination port address, next 32 bits source sequence number, then next 32 bits acknowledgement number. But whenever this acknowledgement flag is 0, then this 32-bit number, it could be all of them 0 or whatever it is, it will be ignored. Acknowledgement number serves any purpose only when acknowledgement flag is 1. Then synchronization flag is 1 whenever we are establishing connection. In the connect request, synchronization flag or SYN flag will be 1. Can you tell me in one connection how many times SYN flag will be 1? For establishing connection, we follow 3-way handshaking process. You send connect request, other party send you connect request and acknowledgement of that, and you send acknowledgement. Once these 3 segments are exchanged, we say that connection has been established. So how many times SYN flag do you think will be 1? Two times. Sorry. It somehow scrolled up and I couldn't see it. Yes, 2 times. Because once when you are sending connect request, then the other party also sends you connect request. So 2 times SYN flag will be 1. Then throughout connection, when you're exchanging data, this SYN flag will be 0. So when you are sending that, we are sending connect request, you know what all we are doing is we are sending this 20 bytes, and here some sequence number will be there, destination port address, source port address, header, and here SYN flag will be written as 1. So it knows that it is a connect request. Now fin similarly, there is finish flag. Finish, whenever we are closing the connection, whenever we are releasing the connection after sending our data, then fin flag will be 1. Finish flag will be 1. So you may say that I want to finish the connection, I want to release the connection. Then other party will be sending you finish plus acknowledgement, and you send acknowledgement and connection will be over. There is one way. Or you are sending finish, but other party still wants to send you data, then it will be just sending acknowledgement. This is known as half closed connection. You have sent finish, but other party has sent you acknowledgement. Whenever it is also done sending you data, it will sending you finish, and then you will send acknowledgement of that. But doesn't matter whichever way happens, finish also will be exchanged 2 times in the normal circumstances. In the normal circumstances, finish also will be exchanged 2 times because from both the ends we are releasing the connection. TCP is having bidirectional connection. Both of them are capable of sending data to each other. And then there is something called RST, that is reset flag. So you said that you want to establish connection. If the server is free and if you are not, listed as a notorious user, then in the normal circumstances, it will grant you permission. But if the receiver is busy with something else, it cannot spare any resources and it doesn't want to establish connection, then it will be sending you reset flag. It will send you acknowledgement back response in which reset will be 1. SYN will not be 1. Reset will be 1. It will say that no, I don't want to establish connection. Reset it. It will tell you that. Then it is up to you. I mean, of course, what will you do? You will also be not sending any data henceforth because connection has not been established. So one way to use reset is the other party is rejecting the connection. You are sending the connect request, but if the other party is not willing, it wants to reject it, then reset will be kept to 1. The other scenario, in the normal circumstances, this I want you to do in the laboratory. Madam is actually doing commands only in the laboratory. So she will ask you to go for FTP. So when you go for FTP, then you can try it. Why am I saying FTP? Because FTP uses TCP at the transport layer. So behavior of TCP you can check there. You will be having, not in the commands, in the Wireshark you should be able to observe that even in a better way. Wireshark is one packet capturing utility. We have some experiments in that. So your packets will be captured and you can analyze the header in them. Okay. So what will you do? You will go for FTP. In the FTP, when you want to quit, then quit is the command, or you can write bye. When you write bye, then also connection will be closed. So when you are writing quit or bye, then internally fin will be sent 1, then you will be getting fin from the other side and connection will be closed. So that is the normal process. Just go for formal or proper connection closing, then you will be able to observe SYN. But if you directly close the window from here, can you see the cursor from this close, this minimization and then this window, maximize in the close. If you will directly close this, at that time, your FTP doesn't have time to let the other party know that, okay, I'm going down. At that point of time, it will simply send reset. It will send reset to the other party that I'm down, I'm going down. Whenever there is any abnormal condition, and if we don't have time for closing the connection formally, then reset will be issued to the other party. Just look at this, how responsible it is designed. Otherwise, you could be closed. Another party will keep waiting and it will send you data. Then it will, start the timer. If you don't give anything, it will retransmit that, and unnecessarily resources will be wasted. So even before, if time permits, then it will send fin, wait for the acknowledgement. It will wait for fin from the other party. It will issue acknowledgement and then it will go. But by chance, if there is some abrupt termination, at that point of time, reset will be issued to just simply inform the other party that, okay, I'm no more available. So are we good with this 4 flags? Acknowledgement is 1, then acknowledgement number is valid. SYN is used for connection establishment. FIN is used for connection release. And reset, whenever connection has to be terminated in abrupt fashion, then reset will be used. So how many of you understood this? Please tell me. Okay. Am I going fast? I try to repeat it and try to maintain the pace, but in case if you feel that I'm going a little bit quickly, then please interrupt me. So I assume that no one is having any doubt so far. Devansh, yes? Is it okay so far? Everything what we have discussed in TCP header, source port address, destination port address, sequence number, acknowledgement number, TCP header length, and this 4 flags. This should be clear. Okay. Then let us talk about other flags. Then we have push flag. PSH is the push flag. So normally, if we think from the receiver's perspective, if you send a segment, then we don't know how receiver's transport layer is designed. It will of course first check the data. If it is intact, if data is correct, then it has 2 jobs to do. It has to send you acknowledgement back and it has to send data to the upper layer. These are the 2 jobs available at the receiver. It will be sending you an acknowledgement in case of correct delivery, correct reception of the data, and the data has to be delivered to the application layer if it is correct and in order. But we don't know how operating system is managing the buffers. It might happen that to minimize the write operations, sometimes it will wait for the buffer to be filled and then it will be performing one write operation from the application layer and then data will be given to the upper layer. So it may happen that temporarily data might be kept in the buffer at the transport layer. However, if you don't want your data to be stored at the transport layer, but you want it to be pushed immediately to the application layer, that whenever data is received, you are not supposed to store intermediately at your level, but if you have to write to the application layer immediately, then push flag can be 1. So whenever you're writing push flag is 1, then transport layer will not store data to optimize the write operation. Whenever it is sending you acknowledgement, then it will be giving data to the application layer as well. So if you don't want data to be stored temporarily, then push can be used. Then there is a flag called urgent, URJ. We have constructed a segment. We are constructing the segment and we are sending that. So in that segment, if there is some urgent information somewhere in between, which you want your receiver to be processed out of order, like you send some data, but then you are sending control C, that is to break this particular thing or something like that. If there is some command which you want to be processed out of order first, then urgent can be used. Whenever urgent flag is 1, that means this usually what will happen, it will start from here, it will process this, it will process options, and then data one by one it will be processing. But whenever urgent flag is 1, then it will not start data from the first byte, but wherever the urgent data lies, it will directly go there and process the data first. Then if need is there, then data will be processed from the beginning. Like urgent pointer is giving you offset of the urgent data. In this particular segment where the urgent data is, that will be pointed by urgent pointer. Urgent pointer and urgent flag are used together. They are used in pair. If urgent flag is 0, this field will be ignored. It doesn't serve any purpose. But whenever it is 1, we will refer to this, we will read the offset, we will go to that place, and that data has to be processed out of order first, and then only other data will be processed. So that is about push and urgent. So these were original 6 flags designed in UDP. Are these 6 flags clear? Okay, then let us go for next 2 flags which were incorporated later on. So ECE is Explicit Congestion Notification. Have you heard ECN at the network layer? Did you come across ECN term at the network layer? It will work along with this actually. Okay, so let me give you a brief about that and then we'll come here if you're not aware about that. ECE will be functioning along with ECN, that is Explicit Congestion Notification. So okay, let us digress for a moment. When we are talking about routers, okay, I want to even go one step further. Do you remember at which layers error control is provided? Error control is provided at which layers? Data link layer. That's it. Transport layer, yes. You know, if you want to give just one name, then it better be transport layer. No, not network layer, Abhi. At network layer, we don't do error control or reliability. Network layer simply is responsible for finding out the best path based on the condition. We don't have, you know, retransmission timer, retransmissions at the network layer. And without that, we will never be able to ensure reliability. Whenever we say reliability or error control, always remember that you will have acknowledgements, you will have timer, you will have support of retransmissions, then only reliable delivery will be possible. So we have error control at the data link layer and transport layer. At one layer it is mandatory. Which layer? Transport layer, yes. And we have seen the reasons. I'm not getting into details again. But at the data link layer, we are doing it for the optimization. Okay. So now the condition is that we are doing error control at the data link layer as well as transport layer. What is meaning of that? At the data link layer, if the configuration is A, B, C, D, then whenever A gives data to B, then B will be sending the acknowledgement, and then B takes responsibility of sending the correct data to C. When C is receiving the data, it will send the acknowledgement back to B. Then C takes over. C will give correct data to D, and then it will give the acknowledgement back. In this entire path, when A transport layer sends data, then D's transport layer receives data, and it will be sending the acknowledgement. So this is what will happen in the networks, in the actual networks. Whatever we are using, this is how our error control is ensured. So what my question is, now that we have data link layer error control as well as transport layer error control, do you think transport layer will have to actually send data? Because if there was error in between, then data link layer would have taken care of that. Will there be no retransmissions practically from the transport layer? Because data link layer is already there, right? So data link layers on the local level, like A to B or B to C or C to D, they will be taking care of the retransmissions. Whenever there is any error, then they'll be sending them. Please try to understand the question. Okay, answer is the next one. I hope, do you understand my question? Others, how many of you understood this? So I'm saying that if we have now data link layer and transport layer together, then will data link layer practically not be doing all the retransmissions, and transport layer will be almost free? Can we say that? Now, that is not entirely true, There are some situations where data link layer will not be able to send the retransmissions, but your transport layer will come into the picture then. In which scenario can you think of that? In case of congestion or in case of traffic. So let us say A has given data to B. When I say A has given data to B, that means A data link layer has delivered data to B data link layer. Now B data link layer has processed it, it was correct, acknowledgement was generated. And now B data link layer, whom will it give data to the? It will pass on data to, no, not C. It will give data to the network layer of B, isn't it? It will give data to the network layer of B. Now network layer is having a queue. Whenever B is getting data from A, B might be getting data from another, or let us say M, it might be getting data from Z. B is a router which might be getting data from 3 sources, and it can send forward data to only C. It can send data to C. So now if it is getting data at 20 packets per second, but it can forward only 10 packets per second, then it will put them in the queue. It will put them in the queue. Do you agree with that? Okay, so let us say queue is of 10, and 10 it can forward. So we should be good. Like it is getting 20, 10 it is forwarding, 10 it is putting in the queue. But now, if the fourth sender is coming and sender is sending 5 packets more, that means now we are getting 25 packets. So in each second, what are we going to do? Forward 10, keep 10 in the queue. And what about other 5 packets? That will be dropped. Yes, that will be discarded. So will this retransmissions be done by data link layer? Is data link layer aware of this data which has been discarded? No, isn't it? Because data link layer responsibility was to deliver to the other data link layer. So A has given to B. A is happy, and now network layer has discarded the data because of congestion or traffic, because it is unable to manage that, it is unable to forward that. So this type of retransmissions will be attempted at the transport layer, because data link layer is not even aware that there is something wrong here. So if this type of packet losses are there, then your transport layer will come into the picture. And without transport layer, we will not be able to do it. So we cannot say the transport layer will be free, because we know that in the real life, the resources are limited, shared, and there are so many users. So often there will be packet drops due to congestion. And then transport layer will have to do the retransmissions and recover from the packet losses. If you are with me, I would like to continue in this direction a little bit. Are we together? Now tell me, I said the queue is 10, 10 can be forwarded. That is why when I'm getting more than 20, I'll have to drop them. But now memory is very cheap. So I have decided that let me have the infinite queue. Infinite is very long queue, so that I don't want to drop my data. My data will be safe in the queue. And whenever in the outgoing link there is availability, I'll be forwarding them. What do you think of this idea? Will it work? Somehow, if I manage to have infinite memory on all the routers, then will we be saved from congestion? Is it a good solution?
And when you click on this,
other things in the queue. And whenever outgoing link available, then from the queue, we can send. Yes, so it will take long time. So what will happen, channel? If it takes long time, what will happen? Timeout. Yes, channel and cable. Yes, Devansh, that is exactly true. Like if you are keeping the queue very large, that means delay is increased. If delay is increased, what will happen? That your packet is not reached to the destination in predefined time, and acknowledgement will not be generated. That means there will be a timeout. So your transmitter is going to send the data again. So retransmission is there. So actually, this is not a good solution, but it is a worse solution, because original packet is there, retransmission is also there, and because we are not dropping anything, we are keeping them in the queue. The delay is almost infinitely long. So no packet will be delivered. All the packets, then retransmissions of the retransmissions, everything will be queued up. And eventually, nothing will be delivered in the decent time limit. So it will fail. So sometimes it is better to, be a bit cruel and drop some packets rather than storing them for the longer duration, because it will not help you in performance enhancement, but it will degrade the performance. So I think we can appreciate this design that router has decided that some will be forwarded, some will be queued up, and then others must be discarded. And if they are discarded, that is okay. There will be a timeout and the packets will be retransmitted. So whenever we are discarding packets at the router, we know that this is because of congestion. So router can send ECN. ECN is one of the provisions available at the router in ICMP. Have you heard of ICMP? Ping, which you have been using in ping is one specific type of ICMP command. In ICMP, there are two type of messages: query messages and error messages. Ping is the query message. Query message always will be in the pair, like you will be sending the query and reply will come to you. So ping falls in that category. Traceroute falls in that category. And there are other type of messages in ICMP. Those are the error messages. So ECN is one type of error message. So we can send this message to let them know that there has been some congestion. What is the advantage of this? So that your sender can reduce the speed. So what will happen? This ECN will be sent to the receiver actually, when the data is forwarding. If you dropped one packet, then in the other packets, you will mark ECN as 1 at the network layer. Then at the receiver, it will be getting this ECE. Whenever it is getting, in this I'm talking about network layer, remember? Yes, exactly. No, not at the data link layer. ECN will be at the network layer. Network layer, not at the transport layer, not at the data link layer, at the network layer. So network layer, that means we know that we can send it to the destination IP address or source IP address, because both of them are available at the network layer. In the IP header, we have destination address and we have source address. So once your destination IP address is knowing at the receiver that there is some congestion, then by violating the error, it is by violating the layering hierarchy, it is informing the transport layer that there has been some congestion. This is violation. Okay, this is violation of the layering hierarchy, because data of one layer should not be used at the other layer. That is why it might not be used very frequently. But anyway, there were 6 bits. So these two are there anyway. We are going to go for 20 bytes. So whether you use it or not, it is going to be 20 bytes only. So this is one of the proposed solution and I'm discussing here. So you will tell the receiver that there has been congestion. So receiver transport layer is getting data from the network layer receiver, and when it is sending the acknowledgement back, in the acknowledgement it will mark ECE as 1, that we have received congestion notification. It will send in the acknowledgement this one. So in the acknowledgement field will be 1, acknowledgement number will be written, and ECE will be 1. So whenever your transmitter is receiving acknowledgement or data from the other party which has ECE 1, then it will reduce the flow. It will reduce the flow. And after reducing the flow, it will make CWR as 1. From source to destination, when it is sending next packets, it is sending congestion window reduced. This is known as congestion window reduced. Please do not bother if you don't understand congestion window. I'll be teaching you well in detail about this. So there is something called congestion window maintained at the transmitter side TCP. It will say that congestion window is reduced. Why will it send that? So that, because router will not just be sending one packet, it might have sent 5 or 10 packets. So receiver is getting those many notifications. So receiver will keep telling that, okay, reduce this, I have got congestion notification. So whenever it has been executed, it will be sending congestion window reduced. So receiver will stop giving the warnings. So this function in pair, your receiver will be sending ECE flag to be 1. And after action is taken, your transmitter will be keeping CWR 1. Are we on the same page? Okay. So that is about these 2 flags. And this is given in the textbook as well. Okay, you can read it, and if you have doubt, you can always ask me in the next class. So that's it about this 8 flags. Each one is 1 bit long. Either it is set or reset. And urgent pointer, we have talked about. Urgent pointer shows offset along with urgent flag. Checksum calculation. Have you done checksum calculation in the laboratory? The same process which you are using at IP, that process will be used here also. But at IP, in checksum calculation, you are having 16 bits just of the header. At the transport layer, checksum is calculated using header as well as data. Header, options, data, whatever you have in the segment, entire segment will be considered, and then checksum will be calculated. That leaves just one field, which is window size. Can you tell me what is this window size? Probably some of you would be able to answer me. What do you suspect it to be? No data length. No. Available buffer size where, Vimal? Yes, Vimal. Available buffer size of the receiver. Yes. Available buffer size of the receiver. We said that, in the flow control, we said that how many buffers are available. That receiver will be telling the transmitter 100. Then you will be sending 100 bytes. If receiver tells you 1000, then you will be sending 1000 bytes or 2 segments of 500 bytes. So it tells you using this field, which is window size. Using window size, receiver reports you the window size. And what should be the value of window size so that persistent timer will come into the picture? 0. Yes. In case if this field is reported as 0, then transmitter will stop the transmission temporarily and it will start persistent timer. So that is our TCP header. Pretty simple, isn't it? Source port address, destination port address, sequence number, acknowledgement number. Header length, this. Check and urgent pointer. And this flex. All of them will not be used together. In the connection establishment, scene is used. For connection closing, fin is used. For acknowledgement, it is used. If you don't want your data to be stored at the transport layer, but push directly to the application layer, or write directly to the application layer, and push will be used. Reset is used in abnormal condition. Urgent pointer is used, urgent flag, whenever you want your receiver to process the segment out of way, like in this segment in the middle, if you want to process some data, then urgent flag will be used. ECE, your receiver's way of telling the transmitter that I know that there is congestion in the network. How does it know? Router has told it. How does router know? Because it has dropped packets. So whenever router is dropping the packets due to congestion, ECN will use, and ECN will result into ECE. And whenever transmitter has taken corresponding actions, then it will tell the receiver that calm down, I have reduced congestion window. So that is our compulsory header. Feel free to ask me if any one of you is having any doubt. There were some flags in the IP header as well. Do you remember them? Which flags were there in the IP header? Try to recall fragmentation. No, flags. I'm talking about flags, Prince. Which flags were there related to fragmentation? More fragments, don't fragment. Yes. Okay. So, can we talk about options now? Options are optional, and hence I thought that you will be doing on your own. I know that was a very bad joke, but still. I want actually, I want you to do some of the options on your own. I'll talk about a few, but I'll not talk in detail about them. Please go through that. I think this sessional's assignment is pending. I haven't given you anything for the assignment. So one of the options is maximum segment size. Whenever we are going for connection establishment, at that time, maximum segment size will be decided. So, can you tell me what will be the value of maximum segment size? Maximum value of MSS. Maximum segment size. What would that be? $100 byte, 1000 byte, 5000 byte, 10,000 bytes. How many bytes maximum can you have in the segment? 20,000 bytes, 1 lakh, 5 lakhs. Oh, come on. You can answer this. No? Okay, then this I give you in the assignment. No, not equal to window size. No. Yes. Based on the window size, you will be sending the data. That is true. But you can decide segments can be of the variable length. Let's please remember that segments can be of the variable length even in one connection. I can send one segment of 500 bytes. I can send another of the 5000 bytes. I can send one of the 7000 bytes. I can send it. But if I declare my maximum segment size to be 11,000 bytes, that means no segment in this connection will be of more than 11,000 bytes. Even if receiver tells you that it can accommodate 25,000 bytes, what will I have to do? Send one of 11,000, send another of 11,000, send third one of 3,000. That is what I'll have to do. So maximum segment size tells you કે દરેક સેગમેન્ટમાં મેક્સિમમ ડેટા કેટલો લખી શકાય છે. That is the maximum segment size. Are we clear on that? Okay. So your window size is different. That tells you that how much data should we be sending to the receiver. So you may send in one segment or multiple segments. And window size keeps varying. While for one connection, initially we'll be deciding maximum segment size. It doesn't change afterwards. Like if you decided 11,000, then maximum segment which will be generated in this one size is not going to be more than 11,000. It can be 10,000, 5,000, 7,000. It can be 5,333, but never more than 11,000. Are we okay? Yes, it will be decided by the transport layer. Yes, it will be decided by the transport layer. But I think you know the constraining parameter which will decide this. What will be the maximum size of this? And it will be decided while, establishing connection. So this option will be used. MTU is one of them. Yes, MTU could be one of them, not necessarily, because it is only wise to have MSS based on MTU. Because if you're keeping MSS larger and if MTU is smaller, then data link layer will have to go for framing. However, if you decide that you want to keep it larger, you may do it, though it is not wise. It can be done. Which buffer size channel? Don't tell me receiver's buffer size. No. That's okay. That's okay. You don't need to be sorry. I was just, trying to tell you that we have just discussed it. That receiver will be saying the buffer size, but you don't. It will keep varying, right? Receiver's buffer size will keep varying. આનો મતલબ શું છે? હું મારી કેપેસિટી કહું છું કે I'll be able to carry 5 kg weight. Then I'll not. Do you agree with that? If you all agree, then I'll be maximum carrying 5 kg weight. I may carry 4 kg. If you say that you can accommodate only 3 kg mango, then I'll be giving you 3 kg mangoes. If you say that you want, 15 kg mangoes, then what I'll do? I'll come once, give you 5 kg. I'll come another time, give you 5 kg. I'll come third time and give you 5 kg, something like that. Now that was a very true, simplistic and pathetic example, but I hope that made some sense. Yes, MSS is dependent on the in the IP you had something called IP length. Didn't you have IP header you should be referring to? Now I'm not going to discuss it. IP header you should be able to discuss. You should be able to recall, and then we will discuss it in the next class. Anyway, so if you don't go for, so Prince, those are there, but there is something else along with this as well. Anyway, so if we don't use this option, if you then default TCP length will be 536. Default segment size will be 536. Not segment size, but payload. So segment size, can you tell me what will be the minimum segment size? Okay, I repeat it. 556. Yes, 556. So you are free to negotiate maximum segment size. But if you opt not to do it, then host will by default go for 536 payload. That means 536 bytes from the application layer you are supposed to deliver if you don't declare anything. And 20 bytes header will be there. So all the hosts in the world should be able to support 576 bytes at the network layer. Your packet size, all of them should be able to cater to 576 because 536 payload, 20 bytes header at the TCP and 20 bytes header at the IP. So 576, all of them must be designed to cater to. They cannot say that I'll be able to process only 100 bytes packets at the network layer. No, it will not do. And maximum segment size in both the directions can be different. It need not to be same, of course, because that is bidirectional parameter. Sequence number will be different. Then buffer window which you are declaring for the other party, that will be different. You can treat TCP connection as two separate connections where one party is having one set of parameters and other party is having other set of parameters. So maximum segment size in both the directions need not to be same. That can be different. So one of the options is window segment size. Sorry, maximum segment size. The next one is window scaling factor. So now we said that, this is how many bits are there in the window size? How many bits do you think are in window size? Yes, 16. There are 16 bits. So if you're writing here 16 So maximum 2 raised to 16 buffers can be declared by your receiver. If you are having just this 16 bits, then 2 raised to 16 bits can be declared by the receiver. But nowadays, that might happen that memory is pretty cheap and receiver may have very larger window size available to you. And if transmitter is also having data to send, then why not to exploit that? Transmitter has data, receiver has capacity. Then just because of this field, we should not restrict ourselves. So there is one option, that is window scale, or let us say window scaling factor. So in the option, window scaling factor can be used. If this window scaling factor is 4, that means whatever is declared here, then it will be scaled by this factor and those many bytes are available at the receiver. So if receiver is having tremendously large buffer available, then it will be able to declare that using window size along with option window scaling factor. Now the next option is timestamp. Like timestamp means when the segment was generated, that time will be used in the option. When it is received, then receiver will be noting down the time when it was received. The receiver will also send the time when the acknowledgement was generated. And when transmitter is receiving that, then it knows that at what time it is received. So what is advantage of this? Your transmitter can know that when the message was delivered. So it knows exactly one-way delay. Using timestamp, you can know that how much you have consumed in the forward link and how much you have consumed in the reverse link. If there is no timestamp, then if you are getting your acknowledgement after 5 seconds, then you will feel that okay, 5 seconds is consumed. So you might feel roughly that 2.5 is in the forward link, 2.5 in the reverse link, but that is not necessary. That might happen that in the forward link, all the routers were pretty busy. So queuing delay was there. And that is why you are consuming 3 seconds, and on the reverse link there was only 2 seconds. So if you want to know characteristics of each of the link, or if you want to know that how much time you have spent in the forward link and reverse link, then timestamp option can be used. This we will do later on. Please ask me if you have any doubt so far. Okay, then we have kept assessment. So at 2:30, Madam has already declared in the classroom, but in case if you haven't seen it, please check it and remain present. Next 15 or whatever students Madam has conveyed, please those many students are supposed to remain present. Thank you.